And we're back. Hey everybody, Mr. Wood here, starting a new chapter. I know it's kind of weird not having a test, but I just couldn't figure out a way to authentically test you over stuff. Plus, with the limited time we have, I'd rather just spend the time making sure you get information so you know what's going on in the world around you as you progress through your life, rather than, bothering to test you over something that may or may not be authentic anyway. So we're here on the Earth Sun system, or the Earth Sun Moon system, and this really gets into Earth's place in space. I'll be sharing the notes with you so you can take a look at that. But the important thing to remember right now is we're looking at Earth as a planet, not Earth as, a collection of continents or rocks or whatever. We're looking at Earth's place in space. So let's go ahead and get started. First of all, we know Earth is sphere shaped. So for those of you who consider yourselves flat earthers, well, you're wrong. Um, First and foremost, obviously, we've been to space. There are pictures of Earth, right? And a more concrete example is the idea of a shadow during a lunar eclipse. Well, unfortunately, here I don't have anything good to really show you this, but the idea is the shadow during the lunar eclipse is always circular. If the Earth were disc shaped, like a cylinder, like a frisbee or something, right? Sometimes it'd be circular when the circle of Earth is facing the sun, but when the circle of Earth is at a side or something, the shadow on the moon would not appear circular, it would appear flat. And then finally, we have the curvature of Earth itself, right? You don't really come into play with this on land because there's too many changes in elevation. Hills kind of ruin this. But on the open ocean, where it's relatively level and flat, the first thing you see is the mast of a ship, because that's sticking up higher off the ground. So as it's, I guess, off the water would be a better way of saying that. So as the ship is coming up over the curvature of Earth, you see the mast first, and then it goes forward. And this works in reverse too. That's why they put people up in the crow's nest at the top of the mast, because that's how they're going to see things they're going to see things there first, right? It's not a perfect sphere, not really that important for you to know right now. It is kind of squished because as it rotates, it squishes down and expands. Not much, not enough to really tell. Here's the stuff we really want to talk about today. Rotation and revolution. Rotation is Earth spinning on its axis, right? And that causes the day and night cycle. As Earth spins, the sun remains in a relatively same spot. So if the sun's here and the Earth is spinning behind it, daytime, nighttime, right? Causing day and night. But the Earth also revolves, and this is the Earth going around the sun. The Earth orbits once at the sun in the focus. It's an elliptical orbit. So if you're mathy, an ellipse is kind of like an oval, and instead of it going around the center, it goes around what's called focus points. Not really that important. Just know that it's not a perfect circle, and this is what causes seasons, which leads me to the next thing I want to show you today. We'll start with this. These are from University of Nebraska, and they are for use with some hardcore astronomy classes. I'm not going to require you to know, for example, what sidereal time is. I just wanted to take a look at this. So here is the sun, all right, and the Earth in a roughly circular orbit. It's close enough for this simulation. And what this shows us is how Earth's rotation and revolution match. So if I go over here and push the button and say advanced by solar day, so I advance by one rotation, notice what happens to the Earth. Spun around once, right? Daytime, nighttime, all the way around. And it's progressed slightly, just a little bit, in its progression around the sun. So let's say I do more. Let's go for a full 10. I'd get really dizzy doing that, but you can see it's progressed more from its original position. And notice we can change the time of day too. Right now, when our little stick boy here, we'll call him Riley, is standing there, and we hit, let's say it's noon right now. How do we know it's noon? Well, because the sun is directly overhead stick boy. If we say, well, I want it to be midnight, hit midnight, notice what happens to the guy. He's exactly on the opposite side. Well, what about sunrise? Well, that's going to be halfway between the two, right? So time progresses depending on your point on Earth. Time is all about where you are on Earth, not where the sun is, right? So let's progress a couple more periods here. In fact, let's go ahead and scoop. We have all the way down here for the year. Right now we're somewhere in April. Let's jump all the way to, say, I don't know, July. There we go, sometime in July. And notice our position compared to where we were before, down here at the 12-hour position, don't worry about it, it's how they tell distances in space, it's very strange, has progressed about a quarter of the way around the orbit. And that should make sense, right? As we add more days, we're going around getting closer and closer to a year, right? Down here, there are things for equinoxes and solstices. We'll talk about those a little more when we talk about seasons. I thought this was kind of neat. This is, of course, the Union at the University of Nebraska Memorial Plaza. So this is right outside the Student Union. And they have a webcam set up. And what they have here is it takes a picture at about 1 o'clock every day, which I thought was really neat. Here's the north, south, east, west, if that helps you out for locations. Notice what happens to the shadow in the series of pictures as we start the animation and let it progress through days. Right now we're sometime in October. We have the shadows and they're going, we'll say about halfway up the picture here and roughly to the base of this little tree planter thing. So let's go ahead and start the animation and take a look what happens to it. Okay, I'm going to pause that. That wasn't a good one. Pause. Let me back it up a little bit. There's a better one. There we go. Nice, bright, sunny day in December. Notice what's happened to the shadow. It's all the way out here now. The shadow got further out. Strange until you look at what's happened to the sun. Right? This is the sun's position according to our observer. Right? The sun is not very high in the sky anymore. Okay, this kind of ties into our seasons of the year. Just want you to take a look at this. Let's keep going. Oh, look. Okay, pause it again. Now I'm sometime in March. Let me find a better and brighter sunny day for us. There we go. That's pretty good. And again, you'll take a look. The shadow is recessed now. The sun is higher in the sky. Again, as seasons progress, the sun's position and the sun's altitude in the sky, the sun's height above the horizon changes. And let's go ahead and get back to, notice in the middle of summer, we have very little shadow. The sun is very high in the sky. And then it kind of goes back the other way until we're about, that's about where we started last time. So it's kind of interesting stuff. And here's the last thing I want to show you for today. Again, relationship here. Here is a 24-hour clock, 12 a.m. midnight, 12 p.m. noon, going around there. You can adjust the observer's latitude. I'm not going to worry about that. And I have it set up right now to be on April 17th, conveniently the day I'm recording this. And you'll notice, stick boy here. This will be a different stick boy. We'll call this one, I don't know, we'll call this one Luke. He has a shadow. And depending on where the sun is. Notice we have the sun here, and we can watch as we start the animation, the sun will set, and the shadow position will change, and it will rise. And not much changes about the sun's altitude over the course of a day. But if we jump, say, a month into May rather than into April, actually go 2 months. We'll go into June. June 19th. That's beautiful. And go back to noon. You'll see the sun is much higher in the sky, and he has a much shorter shadow. Again, kind of the same idea of what's going on with the Student Union, right? As the sun moves, or as the Earth rotates around the sun, the angle of attack of the sun changes, changing most of the world around us. Kind of interesting. And again, we'll tie this into seasons. Let's go ahead and jump to October to see what happens. Do this the easy way. Click. There we go. Notice from October, the sun is not near as high in the sky. We have a much more pronounced shadow. If we go all the way to December, it's lower yet. This is noon, right? The noontime sun in December doesn't ever get much above the horizon. We don't get a lot of solar energy that time, which would make sense. All right, well, that's where I want to leave us for today. Your assignment for this time, make sure you read through Chapter 20, Section 1, and you'll do the worksheets. Let me go ahead and bring those up so you know which ones I'm talking about. Too many pages open. For our packet, we're going to do Earth's Motion Lesson 1, both of these pages. Key Concept Builder, and we'll get to this one later. All right, so pages 18 here and 17. 17 and 18 are your assignment for next time. Hope this helps. Again, if you have any questions, let me know. Have a great day.